Hello, Mrs. Finley here. We're going on to our next lesson on indices now. Remember, indices are just powers. We're going to recap what we did yesterday and then we're going to go on to today's new work. So, if we have a look, remember from yesterday, we worked out that A times A times A times A, because that's A multiplying by itself 4 times, we can write that as A to the power 4. Okay, and then when we look at the next one, we've got a model up here. Look, we've got A's and B's and C's all multiplying together, so we separate them out. So in A's, we've got A times A. So that one's A squared, and we don't need a times now. But next we've got in B's, B times B times B. So that's B cubed, or B to the power 3. And then in C's, we've got a C times C, so that is C squared. Okay, that means exactly the same as A squared times B cubed times C squared, but we don't need the multiplication signs in them because we know in maths that when there's two things stuck together, nothing between them, it means times. Okay, so the rule that we looked at yesterday was if you're multiplying two different powers, or maybe they could be the same powers. If you're multiplying together, then you add the powers as long as this is the same as this. Okay, so the base has to be the same. Okay, so this number to a power times this number to a power, you add the powers together. So the way that that works in reality is if we've got C to the power 5 times C squared, then that is C, and we're going to add the powers, so we've got 5 add 2, which is C to the power 7. We don't need to put this bit in here. It's quite okay to go straight to the answer. Okay, now the next rule that we're going to go on to is A to the M divided by A to the N. Okay, so we're going to work out what that rule is by thinking about some fractions actually. Okay, so the first thing that we need to notice is that if we're dividing, we can write it as a fraction. So y to the power 5 divided by y squared could also be written like that. Okay, dividing fractions, it's top divided by bottom, or numerator divided by denominator. Okay, so we would need to work out what we've got left. So let's write it out in full. So y to the power 5 is y times y times y times y times y over y squared is y times y. Okay, now if you remember from cancelling fractions or simplifying fractions, you can divide top and bottom by the same amount, or you can cancel something on the top with something on the bottom. So basically what we can do there is we can cancel that y with that y and that y with that y, and what that leaves us with is y times y times y on the top, which is y cubed. Okay, so y to the power 5 divided by y to the power 2 is y to the power 3. Okay, let's have a look at this next one with p's in it. So again, we're going to write it out in full. So p to the power 6, p times p times p times p times p times p over p to the power 4, p times p times p times p. Right, so we're going to be cancelling like we did in the last one. So we can cancel any p on the top with any p on the bottom. So that one and that one, that one and that one, that one and that one, that one and that one. So we can see that what we're left with here is just p times p, which is p squared. Okay, so can you see what the rule is? If y to the power 5 divided by y squared is y to the power 3, and p to the power 6 divided by p to the power 4 is p squared, or p to the power 2, can you see what the rule is? Well, let's write it in here. I'm pretty sure most of you will have spotted it. It's because dividing and multiplying are inverses or opposites of each other. It's the opposite rule to when we were multiplying. So remember when we were multiplying, a to the m times a to the n was a to the m plus n. And now we're dividing, it's a to the m minus n. And we can see that in the examples that we just looked at. Okay, here, 5 take away 2 is 3. 6 take away 4 is 2. Okay, so when you're dividing, you subtract the powers. Okay, so this is, oops, I didn't easily keep doing that. This is our next big rule. Okay, and we're going to practice using that just now. So, I'm going to simplify all these things. All right, so to start with, we've got, so g to the power 5 divided by g to the power 3. So we subtract the powers. So it's g to the 5 take away 3. So it's g squared. Because 5 take away 3 is 2. Okay. Now remember that you can write a divide as a fraction. So this means u to the power 9 divided by u to the power 4. And we subtract the powers again. So that's u to the power 9 take away 4. So it's u to the power 5. Okay. The next one, m to the power 20 divided by m to the power 14. Again, remember, subtract the powers. So it's m to the power 6. Okay, now let's have a look at this next one. X to the power 4 divided by x. Now, x doesn't have a power on it here, does it? But what power could we put with a plain x? I think most of you had worked out before that we can put a power 1 with that. Okay, so x is the same as x to the power 1. Okay, so when we're subtracting, it's x cubed. And we can just set this one out just to satisfy ourselves that we're right. Okay, so when we do our cancelling, that x and that x leaves us with 3 on the top. Okay, so it's x cubed. All right, and then this last one here, y to the power 10 divided by y to the power 2 is y to the power 10 take away 2. But so many times in exams that I've been marking, I've seen people write that as 10 to the power y to the power 5 because they forget that you subtract the powers when you're dividing. They divide them. They do 10 divided by 2 is 5, and that's not correct because it's y to the power 8. You have to subtract the powers. Okay? So, let's just have a look at a couple more slightly further on questions. And at the moment, I'm considering these to be extension questions. So if you can do them, that's brilliant. So all we do is we deal with the letters separately. So if we're looking at the x's, we're forgetting about the y's, okay? So x to the power 9 over x to the power 3, or x to the power 9 divided by x to the power 3. We're going to take away those powers. And then we've got y, and it's y to the power 4 divided by y squared. So we're going to subtract. So our answer there is x to the power 6 y squared. Okay, and then this last one, a to the 6 b to the 4 over ab. Remember, a and b both have power 1 there, we can't ignore that. Okay, so we've got a to the 6 minus 1 and b to the 4 minus 1. So we've got a to the power 5, b to the power 3, or b cubed. Okay, so well done. If you've kept up with all that, you can have a go at some practice questions. See you soon.